Here's an example with superposition and a dependent current source. In order to understand that, we need to understand a simplified transistor model with this dependent current source. Excuse me. VG times GM will equal the current. And so VG, since there's no other node mentioned, it's measured with respect to ground. And GM is a transconductance that will convert this voltage into current. And so V out is simply minus GM times the VG times R out, because this current source, which flows in this counterclockwise direction, is flowing against the definition of V out. So if the current is flowing from negative to positive, we actually get a minus voltage. What's happened? What is VG? Well, in this case, VG is right on the node of VS, so VG equals VS. So we can substitute for that, and we get V out equals minus GM VS output resistance. Now, usually there is a series resistance of each voltage source. In this case, we need to be able to take care of it. So same as before, though, V out equals minus GM VG R out. In this case, VG is no longer, though, equal to VS. There's in fact a voltage divider between RS and RN. So while the V out equation remains the same, VG happens to be the source voltage times Rn divided by the sum of them, which is the voltage divider relationship. So if we substitute VG in for V out, we get V out equals minus GM VS Rn divided by the sum of RS and Rn times R out. Now we can begin our superposition example, where I have a DC voltage supply here connected through RD on the output, and I have the input that I had before. So I really need to find V out that's due to this source and V out that's due to VDD. So let's first do it by finding V out due to VS. Replace VDD with a wire of zero resistance. So I took out the voltage supply, and now there's a wire of zero resistance. And you can notice that now that RD and R out are in parallel because they have two common independent nodes. They're both connected to this node and to this node. Now we see that they're in parallel. This happens to be V out. The current is going from negative to positive, and we get the same relationship. VG equals VS Rn, the sum of RS plus Rn. And then we have V out VS, which is GM VG. Before we had just R out. Now we just have that parallel combination. So when we put that all together, we get this equation. The only difference between this and the previous example is that we replaced VDD with a short, and now rather than just having R out, we have RD in parallel with R out. Now let's find V out due to VDD only. Well, let's replace VS with a wire of zero resistance. Now, you might think RS and Rn are in parallel, but they don't have two independent common nodes. They have one common node, and that happens to be ground. So VG is 0 volts. Well, if VG is 0, this current source is at 0. How do we take into that account? Current sources that are set to 0 amps, you just take them out of the circuit. You open it up. But now notice that RD is in series with R out. This node wire here doesn't do anything except label that node out. These are really in series, and now we can see that out is really just the voltage division of RD and R out, which we have here. Now we just sum the responses of out due to VS and out due to VDD. For a reminder, this is V out for VS, and this is V out for VDD. And then we just sum them together. And that's how we can use superposition to rapidly come up with the output response for more than one input voltage.